Hello, a very warm good evening to all of you and welcome to another episode in the series of Explain. Today, we shall be talking about the IPCC report, the sixth assessment report that IPCC has come out with. Now, ever since IPCC has come out with this report in the month of August this year, there have been lots of discussions and rumblings, particularly so in the scientific community. In fact, the United Nations General Security has also termed it to be a code red for humanity. So, what is it that this report contains? In this episode, we shall be discussing about what IPCC is. What are the various types of reports that IPCC comes out with? What are the contents of the report? And also, what are the implications going into the future for various parts of the world? So, let us first of all understand what is this IPCC. Now, IPCC stands for Intergovernmental Panel on Climate Change. It is a scientific body under the aegis of United Nations. It comes out with its periodic assessment reports, and these reports have both a technical aspect to it as well as a generalistic outlook. As you can see, in this year's report, it has been referred to as the summary for policymakers. So oftentimes, when IPCC comes out with a report, it generalizes the language, it trivializes it to such a level that the policymakers and the governments across the globe can take an informed decision, and thereby they can determine the future of the planet. Now, this IPCC was formed way back in 1988. It was formed by both World Meteorological Organizations and UNEP, that is United Nations Environment Programme. Both of them pooled in their expertise to find out what are the scientific evidences which point to the climate change. Because if you take a look into the background, at that point of time, the whole world was debating whether climate change is a myth or is a hoax altogether. So that is why this scientific organization was formed. Now, this organization of IPCC has got three working groups. Working Group 1 comes out and deals with the physical science basis on climate change. So it deals with all the scientific evidences that we have. After going through a detailed evidence when it comes to the research about the aerosols, the emissions which are present, melting of glaciers, ice caps, everything is taken into account when the Working Group 1 comes up with its report. The Working Group 2 looks into the impacts, adaptations, and vulnerability of various different groups and social sections of the society, and how are they able to deal with climate change, or how likely are they to be affected by this phenomena of climate change. Then we have the report which is brought out by Working Group 3. And this report actually deals with mitigation of climate change. What can be done to limit the damage which has already been caused? So all these three working groups, they bring out their own reports. So which is the report that has been released or launched right now, and which is the report which has brought about so much of debate and discussion? It is the report by Working Group 1. So if you look at the timelines of the report, so Working Group 1 has come out with the report that is the physical science basis of climate change. Then in the month of February, the Working Group 2 is supposed to come out with its own report, and then in the month of March, you will have a report being published by the Working Group 3. Eventually, all these three reports which are brought out by different working groups, they are then combined, they are then brought out as a synthesis report, which is expected to be released in September 2022. Now, this timeline might seem very mundane and might seem not very important. But for the examination perspective, especially the prelims examination, one has to understand the various different types of reports that IPCC generates. Now, when we talk about the report that is the physical science basis, this report further has been subdivided into three parts. The first part is the current state of the climate, which deals with all the observations which have been made. Now, based upon those observations, there has been a predictability which has been committed regarding the possible futures that lie before us. And eventually, we also have limiting future climate change, or what can be done from our part in order to limit the damage. Overall, this is a 4,000-page report. So as you can imagine, it consists or it includes various different details and various different scientific evidences. Here, we shall be looking at the basics, and we shall be trying to understand how each and every area of our planet gets affected. Now, what is it that the report tells us? So this report brings to light something that we already have some clue about. None of the findings brought out by this report are actually that alarming. What is alarming, though, is that the 1.5 degree C temperature rise as compared to the pre-industrial levels. Everybody was talking about limiting the global warming to 1.5 degrees C when compared to the pre-industrial levels. And that is what formed the basis for the Paris Climate Agreement as well. But then, this report tells us that as early as 2040, we are going to hit that 1.5 degrees C landmark of temperature increase. And once that is hit, that spells doom and disaster for major parts of the planet. Now, looking at few of the finer details. So, here the report says that the global surface temperature rose by around 1.09 degrees Celsius. Out of this increase till now, 1.07 degrees C has been caused by anthropogenic causes. That is, various causes or various influences exerted by us humans. Now here, it also points out that increase in the greenhouse gas concentration since the 1800s is basically a resultant of human-caused emissions and human-induced greenhouse gases which have been emitted into the atmosphere. Here, it also points out the detail that atmospheric carbon dioxide concentration has actually been the highest in the past 2 million years. And also, when it comes to gases such as methane and N2O, they were higher in proportion than any time when you consider the previous 8 lakh years taken into consideration. Now, this greenhouse gases that we keep talking about, what is the basis upon which we are getting alarmed? What are the basic threats and the basic damages that these greenhouse gases can induce? So if you look at it, suppose this is the Earth's surface. On top of it, we have a layer of gases or the whole layer of atmosphere. Now, when we receive the solar radiation is received as high energy waves in the form of short wave radiation. And that is why it is able to penetrate this layer of gases. Now, when the Earth gets heated up, Earth also starts reflecting back this heat. So ideally, the Earth should have reflected all the heat that it receives. But when the atmosphere is actually dominated by gases such as carbon dioxide, methane, N2O, etc., then these gases form a protective layer. And rather than allowing the heat from Earth to simply escape, these trap the heat. And that is what leads to an enhanced heating of the Earth's surface, which we refer to as the greenhouse effect. Now, here, this report also shows us that even though broadly it is summarized that in the previous 50 years we have received or we have experienced an unprecedented rate of heating, but even during those previous 50 years, if you consider the time period between 2006 to 2018, the heating has been at an exaggerated rate. And even in the year 2020, annual mean temperature was 1.2 degrees Celsius higher or above than normal. Now, this report brings out various different kinds of simulations and various different kinds of possibilities. The possibilities include if from now on we take forward a responsible way when it comes to dealing with emissions, or if we continue our normal way of life and we keep on burning the fossil fuels. So here in this table, you will find that there are 5 different scenarios which have been painted. The best scenario, that is the SSP 1 to 1.9, it deals with the world gaining carbon neutrality, or basically the world adopting net zero emissions by the year 2050. And as per this prediction, you will find that still we shall be breaching the 1.5 degree C temperature rise mark by as early as 2040. It is a different matter altogether that once we attain carbon neutrality or net zero emission standards, then overall, in the long run, we might be able to mitigate the damage that has been caused. But then, if we continue with the way that we are, if we do not regard the planet, and if we continue to burn the fossil fuels as our pathway to development, then basically we are staring at something around 5 degrees C of temperature rise by the year 2100. Now, this 1.5 degrees Celsius temperature rise and the threshold, that is being talked about. But then why this 1.5 degrees? Why not 1.6 degrees? Why not 1.7 degrees? Why does everybody keep on talking about 1.5 degree rise of temperature? That is because this 1.5 degrees Celsius acts as a safety net. As long as the temperature rises within the range of around 1.5 degrees Celsius, we shall be able to still manage the changing environment around us. But once we start breaching that mark, then we start entering into the danger zone. So that is where we have to understand that the first scenario is what we have to follow under all costs. Then there is also a detailed listing of all the emissions which have been carried out. Now here you will find, when you look at the emissions, while carbon dioxide forms the main culprit, and predictably so, but then the other major emission as a greenhouse gas is methane. Now oftentimes we don't consider methane to be that major of a pollutant, but methane damages the environment at an equal rate, if not at a greater rate, when compared to carbon dioxide. Here, in these emissions, you will also find that there are certain compounds or certain short-lived aerosols which reduce the amount of heating. How? So when these small particles or aerosols, such as nitrous oxides, such as sulfate, clouds, etc., when they are present in the regions of troposphere, they start acting as a reflecting surface. So thereby they allow very little amount of heat to actually reach the Earth's surface and cause an overall increased heating. So they act as a preventive shield. So there are certain emissions or certain pollutants which trap the heat, and also there are certain short-lived elements which try to reduce the amount of heat. Now, the most important highlight that the report has pointed out is actually the importance of methane. Now, methane is a greenhouse gas which is released both by natural way of emission as well as the anthropogenic way of emission. When we talk about the anthropogenic way of emission, methane is released from landfills, oftentimes when you dump garbages, and from that garbage very slowly small amount of methane starts dissipating, and small amounts of methane is released into the atmosphere. Then you also have oil and natural gas wells. Then agricultural activities are also in fact one of the major pollutants or one of the major sources when it comes to methane emission. You have many animal slaughterhouses. Every time you slaughter an animal, that also releases a significant amount of methane. Just to understand the amount of damage that this methane can cause, you can understand by the fact that methane is more than 25 times as potent as carbon dioxide at trapping heat in the atmosphere. 25 times. So while the whole discussion revolves around carbon dioxide and limiting the damage caused by carbon dioxide emission, we also have to pay attention to methane. Then, this report makes certain weather predictions and certain patterns which are going to be observed moving ahead if this rate of heating continues. So, the broader prediction is that the land areas will continue to get warmer and warmer as compared to the water bodies. Now, this is no surprise, because when you consider land and when you compare it with, let's say, a nearby water body, the land area gets heated up at a much quicker rate. If this is the solar insolation, the land area gets heated up at a much quicker rate, while the water body takes some time to get heated up. Why is that so? That is because when heat is received by the water body, that heat is distributed within the various layers of the water body. So that is why the water body takes some time to heat up. But the land, in that case, the heat is restricted to the upper few regions or few centimeters of the land. And that is where the land heats up at a very good rate, at a very quick pace, and also at the same time loses heat at an equally quicker pace. Whereas the water body, while it takes time to get heated up, it also takes a considerable period of time to lose that heat. Now, it also says that the Arctic will continue to warm at least at twice the rate as experienced across the globe. So the whole fundamental of Arctic amplification that we already have looked into, that Arctic amplification will continue. And the region around Arctic will get more heated up when you compare it to Antarctica. So the coastal cities around Arctic, they shall also start getting inundated by water as the level of water keeps on increasing. Then at the global scale, extreme events such as daily precipitation increases or has been predicted to have an increased intensity of around 7% for every 1 degree C rise in temperature. So that is where this is the main fundamental which leads to causation of urban floods. We'll look at why and how more urban floods will be occurred at a later stage. Now, this report has also predicted that the tropical cyclones that we come across, these tropical cyclones can get more intense, the wind patterns will become stronger, and eventually they shall be able to cause much more havoc and destruction. Why is that so? Now, one of the basic reasons, or rather one of the key requirements for the formation or development of a tropical cyclonic storm is basically the existence of a warm sea surface temperature. So when the sea surface temperature rises, that provides an ideal condition for the formation of tropical cyclone. Due to the global warming and increased temperature across the globe, the sea surface temperatures are expected to rise much beyond the tropics. Much beyond the tropics. And you will find out that even the seas or even the oceanic water in the region around temperate areas, they also have started getting heated up. This is the reason why the region around Atlantic has been suddenly experiencing much more cyclonic storms. Now there is a reason and there is a cause why these winds will get stronger. As you move away from equator towards the poles, at equator, the Coriolis force that is exerted on any moving wind system, that Coriolis force at equator is actually 0, close to 0. And this Coriolis force is actually maximum as you move away from equator. So as the areas around the tropical or around the extratropical and temperate regions, as those areas away from the tropics, they start getting heated up, the sea surface temperature already is high. The Coriolis force which will be exerted will be much more. So the deviation that is experienced in the wind system, generally when you have a cyclonic system developing, it is developed around a low pressure. When you have more intense Coriolis force, suddenly the winds start deviating quite significantly. And the whole circulatory system of wind and the cyclonic storm gathers a new property altogether. So all the cyclonic storms that we have been experiencing, this is going to intensify moving ahead. And more occurrences of super cyclones are what are going to be experienced. Now, there is also a prediction that moving ahead, the occurrences and instances of heat waves is going to increase quite considerably. Now, what are these heat waves? And why do they increase, or what is the prediction that is made around these heat waves? So when we talk about heat waves, basically we have already seen that the land will get heated. And the rate of heating of the land will be at a rate around 1.4 to 1.7 times. Now, as the land surface gets heated, the air above it will also get heated. Now, when the air also gets heated up, the overall humidity levels in the air, that will reduce. And oftentimes, the land surface will pass through a dry spell. This is the reason why even now, when we observe wildfires and forest fires, even in the region of Mediterranean, Siberia, Canada, United States, all across the globe, there are more and more wildfire events and forest fires which are happening. It is in fact predicted that around 180 days out of a year, major portions of the earth are going to experience these heat waves. And there is a kind of a chronology to it. The chronology is when the continued heating of land is experienced, that basically leads to creation of unusual pressure changes. You will have low pressure regions formed in certain areas, high pressure regions formed in certain other areas, and the whole circulatory model of atmospheric movement, that is the Hadley cell, Ferrel cell, and the polar cell that we know about, all that will get disturbed. Now, all these atmospheric cells, they are responsible for the permanent wind system that we experience. For example, the trade winds, then the westerlies, then we also have the polar easterlies. So in all these different winds and the different wind patterns that we have, they shall get affected. So let's suppose there is an area which is close to water body. Let's say this is land and this is water. Now, under the existing pressure system, if the wind blows from water to land, it will bring about a bout of rainfall. But as these pressure cells, they get disturbed because of unusual heating and cooling caused in different paths, then these wind patterns, they shall be the first ones to get disturbed. And instead of having a kind of an onshore wind, many areas will start experiencing a different wind direction altogether, and that shall lead to unusual dry and wet conditions. Now, what is meant by unusual dry and wet conditions? It refers to a period during the span of the year when the heating will be very intense, but suddenly during certain parts or certain times of the year, you will come across unprecedented amount of rainfall. And that will happen because of the prediction that has been carried out. As you can see, that if the climate or if the temperature increases by around 1.2 degrees Celsius, then around 4.8 times more occurrences of heat waves have been predicted. But God forbid, if we follow the path where we keep on burning and guzzling the greenhouse gases, then these extreme heat waves and heat events are going to be caused at a rate which is around 40 times greater than the present day. Now, overall, you will find that these heat waves, they are followed by extreme wet spells. And that is going to be caused because there is going to be a disturbance of water cycle. Even this year, in our country, we have experienced that how many areas around the central part of the country, they were actually very dry just before the advent of the monsoon and even during the earlier part of the monsoonal rainfall. Now, suddenly, the amount of rainfall increased to such an extent that many areas, especially in the regions around Maharashtra, they have experienced landslides, floods, and a large-scale destruction and devastation. Now, when we say that the water cycle is going to be disturbed, what is this water cycle that we are referring to? It is basically an overall circulation of water through the system of atmosphere, the ground surface, various snow-capped mountains, glaciers that we have, and also the large sea or the oceanic areas. So there is a constant uptake and also a constant provision of water between the atmosphere and the ground surface. Now, because of increased heating of the ground surface, various snow-capped peaks, they are experiencing a reduced snow cover. The glaciers that we have, the glaciers which provide a consistent and constant flow of water across the major life-giving river systems in the subcontinent especially, all these glaciers, they are retreating. Now, when the glaciers start retreating, the water availability or the water security of the whole area, that gets damaged. Lesser amount of water goes into the ground level or underground level, and eventually the cycle is disturbed. Also, when the land is heated at an unprecedented rate, the amount of evaporation that is experienced, also the transpiration from the plants and the green vegetation, that is also increased at an exponential rate. So the ground dries up, but suddenly you will find the formation of very thick clouds. Clouds such as cumulonimbus clouds are formed very instantly. And oftentimes these clouds, they cause thunder and lightning. So with the increased global warming, there will be more amount of sudden evaporation. More amount of sudden evaporation shall lead to formation of these cumulonimbus clouds, which will lead to many instances of thunder and lightning. So we can say that thunder and lightning as events are going to increase. Now again, a question might come into your mind. So what if the thunder and lightning incidents increase? Why do we have to be concerned with that? So first of all, in a country like India, lightning alone is capable of causing multiple casualties. Every year, states such as Madhya Pradesh, UP, Bihar, overall, cumulatively, they experience loss of hundreds of lives due to these lightning events. But also, these lightning events bring about the basic cause which can lead or spark a forest fire or a wildfire. So overall, it is not a good news. Now also, when you will have more sudden formation of clouds, that means a certain smaller area can suddenly experience very high amount of rainfall. And that amount of rainfall, when it is occurring at such an increased quantity, if rainfall occurs at a slow and steady and a uniform rate, it is absorbed by the ground system, by the soil, etc. But if the rainfall suddenly increases, then the ground is unable to absorb all of it. And most of the water is actually drained away as surface runoff, leading to various events such as soil erosion, and also overall all this runoff leads to the sea and increasing the water level in the oceans and the seas. Now, once we have understood these basics, let us understand the impact which has been predicted on the various different regions of the globe. So basically, the impact on polar areas are going to be most intense, and particularly the region around Arctic. It is in fact predicted that at least once before 2050, especially during the month of August or September, at least once we'll come across a phenomena where we don't find any ice at all in the region of Arctic. So think about all the natural habitats for the different types of flora and fauna in the Arctic region. All of that is on the verge of getting destroyed. Now, there is an overall thinning of ice in the Arctic. What are its implications? Here on your screen you can see two different images. One is of a thicker ice layer, one is of a thinner ice. Now, where we have the thicker ice, the overall appearance is bright whitish. And that is because when you have a thick ice layer, then that ice ends up reflecting maximum amount of solar rays. Very little amount is absorbed. But when we have a thin layer of ice, under these circumstances and in these scenarios, this thin layer of ice ends up absorbing the solar rays. And the temperature of water then starts increasing. Water starts getting heated up. The overall melting of ice will suddenly accelerate. Means more areas where you had thicker ice sheets, all those areas will start experiencing a thinner ice. And eventually, the Arctic shall be rendered ice-free. But more importantly, it will bring to life a heating effect, the impact of which can be felt as far as Indian subcontinent. Then, when we talk about the temperate regions of the world, the temperate regions largely refer to the areas lying between the Tropic of Cancer and the Arctic Circle in the northern hemisphere, and the Tropic of Capricorn and the Antarctic Circle in the southern hemisphere. So in these temperate regions, which are comparatively cooler than the tropical areas of the globe, in these temperate areas, extratropical cyclones are actually expected to move poleward. Meaning what? Meaning the temperate cyclones which were formed, these temperate cyclones, if earlier used to be formed in these areas, the southern part, all of this shall move north. So areas which were largely left undisturbed by these climatic events, they shall start suffering. Now, why is it so? Why will these occurrences move poleward? That is because of a simple reason. Temperate cyclones are formed when there is a front which gets created, and in that front there is a low pressure. And how is that front created? When you have a region where the cold air actually interacts with the warmer air, which has a larger volume by virtue of being warm. So when this kind of interaction takes place, that eventually can develop into a temperate cyclone. Slowly, as the globe and the earth is warming at an unprecedented rate, the warmer air will become more and more powerful. It will start pushing significantly northward, and it will lead to temperate cyclones in the regions around 60 degrees or 55 to 65 degrees north and south latitudes in both northern and the southern hemisphere. Now, there is going to be a shifting of the pressure belts as well. These pressure belts are going to be shifted because of unusual heating experienced in different parts. When the pressure belts shift, the jet streams which are formed over these pressure belts, they shall also experience a subsequent shift. Now, how will that affect us? So recently, you would have come across the formation of heat dome in the region of Canada, where the temperature of the Canadian Shield increased to a record or a staggering number of around 49 degrees Celsius. Siberia has been experiencing an increased temperature for the past few years. All of that is because of one of the influences of jet streams. The jet streams, where they exist, they don't allow the air to rise up, leading to an increased rate of heating over a prolonged duration. So all these events of heat domes, they are here to continue, and their impact is going to be felt across the globe. Then the impact on smaller islands. So this is a kind of a general awareness that almost all of us have, that when the overall earth gets heated up, there is going to be a sea level rise. And when there is going to be a sea level rise which is going to be experienced immediately, it is the islands, the smaller island nations, which are going to be impacted. Now, the smaller islands, not only are they going to be impacted by the sea level rise, but there is a prediction that these islands, other than being flooded and inundated with oceanic water, they are also going to experience unprecedented level of droughts. Why? That is because under normal circumstances, these land areas will continue to get dry. The overall moisture availability, the absolute humidity of these areas are going to reduce. And when the air lacks moisture within it, then overall the crops will start dying. And that is where the soil moisture eventually is also depleted very soon. So it is predicted, in fact, that the islands, especially the Caribbean group of islands, they are going to lose their moisture availability very soon, and they are going to encounter agricultural droughts for a long period of time. So they are going to suffer, all these small island nations, they are going to suffer the double whammy. Not only are they going to experience floods, but also droughts and possible famines at the same time. Now, after this, the impact on oceans. Oceans overall, perhaps, are going to experience the maximum impact due to this global warming or temperature rise. Now, the sea level has experienced a rise of around 20 centimeters in the past 100 years. But then, this rise of sea level has mainly been exaggerated in the previous 20 to 25 years as per this report. Now, this report also gives us the three various reasons which leads to the sea level rise. First is the increased surface runoff. So, we have seen that how when the hydrological or the water cycle gets disturbed, the overall surface runoff not only becomes intermittent and unpredictable, it also leads to an increase in the amount of water which moves into the sea. Because when you have sudden onset of increased rainfall, very less amount of water is absorbed. Also, there is going to be melting of ice across the various ice sheets and the polar areas. When there is going to be a melting of ice cover and ice caps, that will also lead to a subsequent sea level rise. But there is one factor which we oftentimes tend to ignore when it comes to sea level rise. The general perception is that the sea level will rise only because of melting of ice or melting of glaciers. But the single most factor which has been responsible for or has contributed to more than 50% of the sea level rise as has been experienced is the thermal expansion. Now, what is this concept of thermal expansion? Well, it is as simple as the name suggests. When you heat any object, that object tends to expand. So, when we end up heating a water body, overall the water body, after getting heated up, it will have its molecules moving slightly further away, because then the water body will have or would have inculcated more amount of energy. So, overall the water is going to experience a very slight amount of thermal expansion. So, this thermal expansion, by the way, is one of the major causes leading to sea level rise as has been witnessed in the past century. This can form a very important fact for the prelims examination. So, one should be very aware that thermal expansion is the leading causes. Now, this report has actually pointed out certain areas of the globe, such as the Indian Ocean, Western Equatorial Pacific Ocean, that is around the region to the north of Australia, Western boundary currents, the ocean currents that we have across the western part of the oceans. All of these are going to experience an increased rate of heating. And this overall heating shall have multiple consequences. Some of the consequences are ocean stratification. What is this ocean stratification? Stratification refers to arrangement of anything in various different layers. So, when we talk about ocean stratification, it is a concept where the water within that ocean will get arranged into various layers. The water on top will have lowest density. The density level will be the lowest, so it will tend to float over. Then the water in the lower regions will have a very high amount of density, and it will tend to remain at the bottom. It will tend to sink by the influence of gravity. Now then, you may ask, so there is an ocean stratification which is going to be caused, big deal. What is going to be the impact of it? So, when water gets arranged into various layers, means there is a lack of mixing of water within the ocean. When there is a lack of mixing of water, so the species or the organisms which live at the bottoms of the ocean, which we refer to as the benthos, all those species, all those organisms, they shall be devoid of natural nutrients. The natural nutrient cycle within the ocean, that will get disturbed. But again, here, once the water gets arranged into layers, that means heating of the top layer becomes furthermore facilitated. And when the top layer gets heated at an increased pace, what will happen? Sea surface temperature will go beyond 27 degrees Celsius. And once that happens, there will be formation of tropical cyclone systems across the globe. So ocean stratification is going to further aid formation of more tropical cyclones and extreme weather events. Other than that, we have also experienced an increased rate of deoxygenation up to a depth of around 2 kilometers from the surface of the ocean across various water bodies. And this happens when the temperature of water goes up, the dissolved oxygen content automatically starts depreciating. And that spells disaster for the species, the marine species. But other than this, we also have ocean acidification, which dawns upon us, and there is going to be a change in the Atlantic meridional overturning circulation, or what we refer to as an AMOC. Let's look at these two in a particular significant detail. Now, when we talk about ocean acidification, before looking into this, we have to understand the fact that oceans across the globe, they actually act as a sink for absorbing around 50% of the carbon dioxide emitted in the atmosphere. So they are the natural reservoirs where the carbon dioxide goes into. But what happens if suddenly the amount of carbon dioxide emitted in the atmosphere increases? When the amount of carbon dioxide in the atmosphere, that will go high or that will increase. That means more carbon dioxide will be going or entering through the water-air interface into the oceans. And when you have more carbon dioxide entering, it will start interacting with water molecules as well as the various different carbonate ions or the salts that are present. Overall, this chemical reaction leads to formation of bicarbonate ions. Now, these carbonate ions ideally are used by various different species to form a shell around them. So all the crabs, mollusks that you come across, all those who have a shell, all these species will find it very, very difficult to form newer shells because there will be an absolute lack or dearth of carbonate ions. So consumption of carbonate ions from these oceans, that will impede the calcification process. And the ocean slowly starts turning acid or acidic because of formation of carbonic acid due to these bicarbonate ions. So this process or this whole procedure by which the ocean waters slightly turns acidic or its pH level slightly starts reducing, that is what is referred to as acidification. Now, various different species such as clownfish, their larvae, they are unable to spawn at various places as the water is turning acidic. And this has been observed in this report. And basically you will find this image actually depicts it, that how a species which ideally would have formed a brilliant shell around it, slowly and steadily when the carbonate ions they get removed, these species they are on the verge of extinction. So when we increase our carbon dioxide emission, the oceans they start getting acidic. Then there is going to be an impact on the AMOC cycles or the Atlantic meridional overturning circulation. So very briefly, so what is this AMOC or this Atlantic meridional circulation? So here you will see that surface water tends to flow from the various regions. As they reach the colder areas or the polar regions, these surface waters they become colder. Colder water is more dense, so it tends to sink. And once it sinks, then it starts flowing as subsurface current throughout the various different oceans. So this is what is referred to as an overturning circulation. A major part of this overturning circulation is actually experienced in the Atlantic. And that is caused by actually one of the most powerful ocean currents that we have on the globe, and that is the Gulf Stream. Now, as the oceanic water across the globe will get heated up, then cooling of this water shall be impeded. It will not sink down so quickly. So overall, the whole circulation will come to a stop or will become increasingly slow. What will that mean? Again, mixing of nutrients across various oceans will not happen. And secondly, once you have warm water staying over a region, Gulf Stream carries warm water. And if Gulf Stream stays where it is, more tropical cyclones, because the sea surface temperature will be very, very high. So this is where we will have an effect on the various different areas of the globe. But then, what about the impact on urban areas? As we are aware that the world is witnessing an unprecedented rate of urbanization, that means the concentration of urban areas across the globe are increasing. Now, these urban areas, by virtue of absorbing all the different types of heat because of the concrete structures, they end up creating a urban heat island kind of feature. And if you have more urban areas in any particular continent or subcontinent, means what? Overall temperature will rise. But then this unpredictable bout of sudden rainfall will then test all our urban systems, and we will come across more features or more occurrences of urban floods. And this is something we are already experiencing, especially in a country like India, where our infrastructure is not to that given standard. These sudden bouts of rainfall will surely flood almost all the metropolitan and megacities that we are building simultaneously. Now, once we look at the overall picture, what is the impact on India? So when you talk about the impact on India, not only is India going to suffer from this dry and wet cycle of climate, because regions such as Vidarbha in Maharashtra, regions such as South Bihar, Eastern UP, many of these areas, they experience sudden onset of floods, and within 2 months, drought-like conditions, so the crops start failing. So these events are going to increase in their frequency. But other than that, there is going to be an impact on the monsoons. The monsoons are going to become unpredictable. As of now, the monsoonal rainfall in India is not being impacted that much because we have a significant amount of emissions caused by aerosols, particularly sulfur dioxide. But then this sulfur dioxide emissions, these are bad for our health. So the solution cannot be that let us have more aerosols in the air so that we have more rainfall. No. Eventually, the monsoonal system in the whole of the Southeast Asian region is going to be impacted quite significantly. Now then, there are certain technical terminologies used. Let us understand that. One is the thermal inertia. What is this thermal inertia all about? Inertia refers to the state of continuity. Thermal inertia refers to the concept that even if suppose today we stop all the emissions, we stop all the ways in which the earth is getting heated up, does not mean that from tomorrow cooling will start. The water bodies, as they take more time to get heated up, significantly they take more time to lose that heat as well. So all the oceans that are getting warmed up, they will continue to get warmed up to a significant period beyond when the heating stops. So that makes us aware that we have to stop the heating as soon as possible. Then we shall be observing the results or the fruits of it in the coming future. That is what we have to refer when it comes to thermal inertia. Now there is another concept, and that is of radiative forcing. Radiative forcing is actually a measure of the changes which occur in the heat budget of the planet by various different natural and anthropogenic causes. So for example, let us say that there are huge emissions of nitrous oxides, the ground level ozones are being formed, then you have increased emission of carbon dioxide. All of that will push back the heat on the Earth's surface. So the Earth's surface, which was ideally supposed to lose all that heat, will end up gaining that heat. This is a kind of forcing, heating by forcing, and that is what is referred to as radiative forcing. It is measured by watts per meter square, which is the energy received in small area. Here again, you have positive forcing that is exerted when climate factors contributing to, or they actually lead to warming of the surface. That is positive forcing. Negative forcing, on the other hand, is what brings a cooling effect. So for example, certain short-lived aerosols, certain cloud covers, they lead to a cooling effect. So that is what is referred to as the negative forcing. Okay? So if you take a look at this concept of forcing, you will find that greenhouse gases, they have an impact of positive forcing. They lead to heating. But then when you have cloud cover, that leads to a cooling effect. So it is a kind of a negative forcing. Again, a concept important for your prelims examination. Now, you would have observed while we were looking through this report that basically we have compared it, that unprecedented rate of heating in the past 1,000 years or 100,000 years and so on. So that can raise a question in your mind, that it means that at one point of time in our past, the Earth would have also heated up to this level. So that means the Earth is retracing its path back. So what is this natural heating and cooling cycles of Earth? It is understandable that under the present day circumstances, because we are causing so many emissions, the Earth is getting heated up. But has it happened before? The answer is yes. So every few thousand and every few 100,000 of years, the Earth heats up, subsequently cools down at a greater rate. And this is because of change in the orbit of the Earth. As you can see from this figure, the first case, you will find that the Earth's orbit is almost symmetrically circular. Whereas in the second case, you'll find it is largely elliptical. So this orbit of Earth keeps on changing. Other than that, its axial tilt also keeps on changing. All this refers to a variation in the amount of solar insolation received by the Earth. Because when the distance from the sun changes, when the different parts of Earth start receiving different amount of solar rays, the heating and cooling cycles will obviously get impacted. These are what are referred to as the Milankovitch cycles, which lead to the normal heating and cooling of the Earth. Now then, once you are aware that the Earth naturally passes through this heating and cooling cycle, so why is there an alarm which is being raised now when we are observing this heating? That is because of the sudden nature of the changes. Suddenly the temperature is rising, and what that has led to increased intensity of the weather events, the climatic phenomena. Various different species that we have, they are unable to adapt to these changes, and as a result, many of these species, especially the marine animals, they are altogether shifting to the polar areas because they want or they are in search of slightly cooler water. Even 1 degree C change in oceanic temperature can lead to an end of life cycle for many different marine species. Then this has already caused irreversible damages to the environment in terms of melting of glaciers, in terms of erosion which has been carried out. All those cannot be taken back. But just because it doesn't happen again, it doesn't happen in various areas, we need to be aware of what we need to do. So what is it that we need to do? What can be the plan for mitigation? Basically, regardless of any step that you take, climate change is here to stay. So rather than putting all our focus on mitigation or stopping this rise of temperature, it will be stopped provided there's a general consensus, but it will take some time. Till that point of time, we have to focus on climate adaptation. We have to adapt to the changing environment. We have to develop more early warning and more weather observation systems. Only around half of the total 193 members of World Meteorological Organization have state-of-the-art weather services and weather stations. That needs to change. We still do not have the ability to capture data from the Latin American countries, from the African subcontinent, and many small island nations in the Caribbean. And that hinders our understanding of the change of climate. So we have to be bold in terms of accepting what we need to do to adapt. We have to put more money into newer technologies. And we have to be able to predict events such as cyclones, because these are going to happen much more frequently. So if these steps are taken care of, we shall overall ensure that in the coming future, the kind of damages that can be caused because of the global warming and because of the increasing temperature, all of that can be put to a halt. So, to summarize it all, what is it that we have looked at in this particular episode? We have looked at what is IPCC. We have looked at what are the reports that IPCC generates. We have looked at the various different predictions that it made. We have looked at the various possibilities, different rates of heating and cooling, and their impacts in different regions of the world. We have come across few technical aspects, why there will be more tropical cyclones, what will be the impact on humidity, what will be the impact on heat waves, what is thermal inertia, what is radiative forcing, and also we have looked at the mitigation strategies. All these can form very important questions when it comes to the prelims examination as well as subjective questions in the mains exam of UPSC. So, hope that you extracted something out of it. Thank you for being with us. Goodbye.